Okay, so now we come to one of the last topic of this lecture, which is how to mitigate the bias. What are the methods which are readily available? So Galagos et al. They have kind of classified the proposed methods into 4 categories, and one of the categories pre-processing, where we kind of change in the data set itself to debias. In training, where during the time of training or during in the model itself, we are trying to tweak something so that the resultant output is debiased. And it could also be intra processing, where we after training, so we are not changing the weight, we are not changing the parameter, but we do some sort of analysis. We do after the training, we do some kind of transformation which will kind of debias the output, which will debias the model. And then post-processing, so you rewrite something. So you generated an answer, you generated a text, and then you rewrite with the help of another model or maybe a debiased model, and then you get a debiased sentence or debiased generation, right? So these methodologies are there, right? So in pre-processing, there are multiple methods. So data augmentation, where you might want to augment samples which are, let's say you have women versus male, let's say gender bias is there in a particular data set, and there are less representation of female samples, females in the overall samples. So what you want to do, you want to augment more samples which are representative of females, right? So it's a sentiment classification, and you have most of the data is coming from men. You don't have women representation there. You might want to add more samples which are representative of women. Then data filtering and rewriting. So you might want to rewrite some of the samples to make it, let's say you want to, and we'll have some examples of it, and you want to filter out some of the biased samples, and you want to rewrite some of the samples so that to make them neutral, right? Data generation, you might want to generate new samples which are debiased, and then you want to train the model, right? In a very layman term. Instruction tuning, so as you know, right, you put the instruction and allow model to align itself to the instruction, right? So prompting, right? So you want to ask model that you need to do this instruction, you need to follow this instruction, and then the model needs to kind of adhere to that instruction. And projection-based mitigation, we have already seen that some of the methods we have seen earlier. That's the older method where we reduce the projection over the gender direction by reducing the components of the vector and so on. In training could be architecture modifications. You might want to change a bit in the architecture so that the resultant model is debiased. And loss function modification, you might want to add a particular loss. You devise a loss which caters to biasness, which kind of penalize the biasness, right, to emphasize on neutrality and so on. And you also might want to do parameter updating, which is selective, right? So adapter, right? So we had discussed about adapter. So rather than touching the original weights of the model, we add a layer, additional layer, and we just train that layer, and that layer, it's easier to train because less number of parameters requires less number of samples. You train it and you add to the original model so that resultant model, the effect will be neutral or debiased. And you can also filter out some of the model parameters. So given a model, you can select that particular region in the weights, or some of the weights or some of the layers are responsible for biasness. We want to select them with some heuristics, and then we need to remove them or maybe zero out them, right? Intra-processing will contain decoding strategy. So you might want to change how you decode the sentence, right? So you are using beam size k versus you are using beam size of k dash, right? So you are changing the beam size. You might be changing how to select the particular word from the probability distribution when it comes to selecting the word, right? So not greedy versus something else, right? Nucleus sampling and so on. And weight redistributions, you might want to redistribute the weight of different words, input words, right? So that model not give emphasis to a particular gender, race, religion, and so on. And modular debiasing network. So you might want to add a network altogether, a particular network which is debiased already, which is good at, which is debiased, which is neutral, and you also add additionally that network with your model, right? So this is intra-processing, and then rewriting, post-rewritings, right? So you generated the output already. This output will be fed to another model, which is, let's say, debiased, and it will rephrase it, rewrite it so that it becomes neutral, right? So it was kind of a summary of the all proposed methods when it comes to debiasing for LLMs. Right, so this particular diagram, it shows the overall picture what is happening. So you can see in a typical pipeline, you have input, you have LLM, and then you can do pre-processing. So pre-processing methods will work on the input, and then in training methods will work on the training time itself. So they might change the infrastructure, the architecture and whatnot. And intra-processing, they will transform after the training, they might transform the data or the intermediate data. And output, you might want to do post-processing, where you want to rewrite some of the things, rephrase some of the things, and then you get a debiased output, right? So this is the overall pipeline. And in terms of pictorial depiction, same thing is there. Let's say for pre-processing thing, he worked as an inventor, so you might want to change to they worked as an inventor, so that this gender specific thing becomes agnostic of gender. And so this is kind of rewriting in pre-processing. In training, so you modify the parameters of gradient based updates. So you might want to change based on the gradients. You see that these parameters needs to be catered to, this need to be modified. So you select those parameters, you change those parameters only, and this kind of a example of in training. And then intra-processing could be modifying the inference behavior without furthering training, right? So you do change in the decoding scheme, you change the parameters of decoding, you might want to change how you select the words and so on, right? So intra-processing. And then post-processing, like there are some curse words, and at his job, rather than saying, you say good versus there, right? So you kind of change it into an intended neutral format, right? So a more positive format. So that's called rewriting. Okay, so pre-processing, when it comes to pre-processing, we have examples in detail, and we can see here. In case of augmentation, what we do, so we had these methods, right? A way of kind of methods, right? So in augmentation, what we were doing, he worked as an engineer, she worked as a nurse. You might want to add she worked as an engineer and he worked as a nurse also to this, right? So augmented more samples and feed to LLMs. In case of filtering, she is well respected, all women are curse word, let's say. Then you might want to remove it. So this kind of filtration. So you filtered out this bad input and you retained the good input, right? So here you are adding these two things to this original. Here you are removing these not so good samples or sentences. Reweighting. So I am an European author, I am an African author, so you might want to give equal weight to them, or maybe more weight to the African author because of less representation, and less weight to the European author, right? Generation could be she was independent, he was gentleman, she supported herself. So you might want to generate a word which is related to this and then add it to and he conducted himself polite. So you might want to rewrite this to make it more neutral or made it more downvoted, right? So make it more subtle. Then instruction tuning. When it comes to instruction tuning, you can have modified prompting language. So let's say you say Muslims are helpful to start with, so starting with a positive note, and then you start Muslim man worked as blah blah blah, hardworking Mexican people. So you add a hardworking to the Mexican people, so that model gets to have a positive positive connotation or positive attitude towards the Mexican people and Muslim people, right? So this is a modified prompting. And control tokens. So you can give let's say more weight, equal weight to the feminine and masculine genders, or maybe a different kind of weight. So more weight to feminine, but less weight to the male gender. So you specify this in the prompt itself, model gets to know that how you want to control the generation, right? And the continuous prompting could be you add additional tokens and which will be learned by the LLM. So, and it will go back to this, you will with the error, and it will try to learn a better representation. You will compute the biasness metric, and then the error will be propagated back. So moving forward, Now, the next method is in-training mitigation of biases. And in this, we had seen multiple categories of methods. One of the category was architecture modification, where maybe, let's say this is a transformer having multiple layers. We might want to freeze one of the layer, or maybe make it trainable, non-trainable, and so on. And this will affect maybe this layer itself is responsible for learning some gender specific things, and we want to freeze it, and we don't want to learn those things maybe, or vice versa, and so on. Other method in this category could be change in the loss function itself, or maybe adding a different loss function. And let's say this is this word is man, and w dash or w prime is woman, and we may want to devise a loss function which is some sort of function is calculated on top of this word, these two words, and the difference between two, and we want to minimize this difference to neutralize it. So there should not be any difference between the representation of man and woman in the model, right? So, and this loss is back propagated to your model, right? So this kind of a loss function based methods. Then selective parameter updating could be the adapters, what we had already discussed multiple times. So we, rather than changing the weights of your pre-trained model, you might want to add a layer of adapter, and then you want to change that layer of adapter. Maybe you want to learn or fine tune this adapter with a smaller data set which is manually curated, and that kind of caters to debiasing, or it's a neutral data set. And then you kind of add this to the original weight to have the resultant kind of resultant effect what you can get after addition, right? And then there are some advanced methods where within a particular layer you may want to find out what parameters or region of parameters are there. If we kind of omit them, we zero out them, or maybe we remove them, we have a better model when it comes to biasness, right? So it's a it's a biasness sensitive model, or maybe it's a debiased model. And how to do that? You can feed multiple variations of a sentence. So let's say with he, with she, you multiple perturbations of the sentence, and you found out that depending on, let's say, you can learn the dropouts, right? So these units are dropped out, and with this dropout it works well. So you might want to omit those units, or kind of zero out those units or the neurons, right? So this is the another set of model which they proposed. And the last what we had seen is so second last is intra-processing mitigation, where you don't have to touch the weights of the model or kind of a processing of the model, but on top of that learned model you might want to do something. So you can change the decoding strategy, right? So let's say there is he is decoded, and then is a doctor decoded, or she is decoded is a, and then it is decoding a slur, kind of a slang, or it's curse word. You don't want to kind of visit this branch, right? So you can have a very intelligent way of decoding it, where you don't want to visit where you which is not a good branch, where it's not a good exploration, right? So you don't want to explore this branch. On top of that, there are other methods which researchers have proposed, is modified token distribution. So let's say the distribution of the next word is he, she, and then this curse word. You might want to modify it so that it kind of neutralizes a bit, right? So you might want to give less weight here and a bit more weight here, right? So more probability here, less probability here, right? So you might want to kind of flatten it out a bit rather than a skewness which is there. So a spike at he which is there, and you want to reduce this for this curse word, you want to reduce a lot, right? So you can devise an intelligent technique, and people have already proposed many methods. You can change the distribution of the next word, probability distribution of what should be the next word, right? Another set of problem in which is categorized into this class, intra-processing mitigation, which is weight distribution. So maybe you know attention mechanism very well now, and C is a doctor and the curse word, she is a doctor, and the curse word also given some importance in your original attention map. What you want to do, you want to reduce the score of attention map here, You want to reduce the score of attention map here, so you don't give attention map to here, score to here. You give more attention weight to doctor, right? As simple as that. And modular debiasing network, you could have on top of LLM, you can apply another gender network which might be trained with auxiliary data set, which is manually curated by people and which learns to kind of generate or modify your output with the gender specific neutrality. So it will kind of neutralize your text generated because of this gender specific data set it kind of trained on, right? So you can have a race network, you could have gender network, could be region network and whatnot, right? So you can add additional network to it. And the last category of method, which is post-processing mitigation, which is super simple. So if we go through this diagram, so we have an LLM and it generates, let's say the mothers picked up their kids, he is the CEO of company. So it clearly mothers only picking their kids, they cannot be CEO of company, but a man could be CEO of company. What you want to do? You want to detect what tokens are the gender neutral versus not gender neutral, having some biasness. So you detect mothers and he, and then you put it to a generative model. It will kind of rephrase it like this. So the parents picked up their kids and they are the CEO of the company, right? So it will convert this into more neutral to the gender, right? So gender neutrality is maintained. And then you might want to neural machine translation models, you might want to translate it into a different language and you also put it, right? So in different language if it is required, right? So all these scenarios can also be covered.